Guys, it's easy not. I know I'm preaching to the choir here because I know you guys are actually attending, and I'm actually talking to the guys that don't attend. Guys, I know it's easy to fall back and say, yeah, but there's a recording, I don't have to attend. But how many people actually go and watch the recordings? That's the scary part. You tell yourself, listen, yeah, there's a recording, I'll go and watch it, but you never do. And like I said, I know I'm preaching to the choir. You guys are here, actually. I'm preaching to the guys that aren't here. But it's a dangerous thing to say, yeah, it's fine, there's a recording. But then you actually have to watch the recording. And when there's 4 recordings or 5 recordings of 1.5 hours lectures, then it becomes a lot. So guys, please just maybe encourage your friends to attend. I always say that attending class is easy. Working through the textbook or working through the notes on your own is difficult. When you're in class, all you have to do is sit and listen. Yes, it takes time, but that's all it takes. You just have to sit there and listen, and then the information comes into your head. But if you have to go and sit and study and work through the textbook and work through the notes and work through everything on your own, and half of the stuff is stuff that maybe you haven't seen before and stuff, then it's very difficult. It's very easy to attend a class and get good marks. So with that, I'd just like to encourage you to attend the classes and encourage your colleagues, your fellow students to do the same. It's the easy way out. It's literally the easy way out. And a very good engineer once told me, a good engineer is a lazy engineer. Ne? So why do something difficult when there's an easy solution? A good engineer is a lazy engineer. So I say that with a smile on my face, but maybe that's good advice. Ne? Work smart and not harder. And one way to work smarter is to actually attend class. All right, guys. I see with my rant, there's a couple of more students that logged in, so I want to start. I want to start with some feedback on yesterday. We all know the natural sciences test, and a couple of people were upset. And yesterday, I think there were 7 students that came to chat to me at campus, and we had a long discussion and a good discussion. And we came to the conclusion that there isn't another option but to rewrite because the test was compromised. And even that already is a little bit lenient in regards to just say, let's rewrite the test. So that was the conclusion, is that we will rewrite the test, but I'm going to accommodate you guys by incorporating that natural science work into the test that will cover chapter 1 and 2. So it's just one test, it's the same amount of preparation. So we'll just incorporate that work into that test, and with that way, hopefully support you guys with your limited time and the mini modules that you have. The second part also said was that students felt it is unfair, and I agree, it's very unfair, that one student maybe compromised the whole class test effort. I agree with that. And they said, okay, then we must follow procedures with that student, maybe in a form of justice or whatever, even though justice will then be left over to me in my judgment. And I don't think that we can ruin a guy's entire career for one mistake that he made. That doesn't mean that he mustn't be accountable for what he did. It just means that everyone makes mistakes, and how you handle those mistakes is your integrity. And the student has contacted me, and I am going to have a conversation with him, and we are going to talk about how accountability in this regard works. Okay, guys. So with that, just give me a moment. I just want to close the window. So with that, guys, you're third-year students, né? Next year you'll be engineers. Most of you are already working as engineers. So we can't afford to be accountable engineers and let something like this happen. So guys, in future, please do take that responsibility. Study, do things right. I think our country is in a state because people aren't accountable for what they're doing. And people from the past have also not been held accountable for what they did. So I think that's why we are struggling to a certain extent here. And the only way to change that is to start with ourselves and the people in our with which we have contact, and help them be accountable for their actions. So guys, let's take this forward, and let's make it something great. Okay, thanks. Okay, that's the end of that. So I'm not going to talk any further on that. Guys, do you have any questions or comments that you'd like to make before we start? Maybe by show of raise of hands. No hands. Everybody happy? Great. Great, great, great. Okay, guys, we're busy with chapter 3.
Good morning, sir.
Yes, yes.
Sorry, I was trying to raise the hand, but it's a bit tough here. Apparently, from what I'm seeing, a student can only have access to the recording he attended.
Yeah.
Is it right?
I don't know how it works, but it seems right to me.
So, for example, if a student is not attending this class, he won't be able to access the recording.
Yeah, yeah. Guys, do you know what the policy is on class attendance? Student rules and regulations. And those student rules and regulations apply also to online classes, no?
Okay.
So, class attendance is compulsory, and it's your responsibility. It even goes as far to say that when there's a problem, TUT can actually go back to class attendance registers and then decide not to accommodate the student. Do you know that the student rules and regulations actually say that?
No, wasn't aware of that.
Yeah, so it's a dangerous thing talking about, yeah, but the videos for the lectures aren't available. You've got a timetable, and when you enroll and register with TUT, you comply or you agree to comply with student rules and regulations. And student rules and regulations say that class attendance is compulsory. And it also says that if the attendance is poor and the student has a special case and TUT considers that case, they can actually take class attendance into account and refuse to assist. It states it stronger in the student rules and regulations than I'm saying. So we can try and accommodate you guys and all of that, but remember, I'm also an employee of TUT, which means that I am also in the position made to enforce those rules and regulations. So those are my guidelines as well. So I want to accommodate you guys, but class attendance is compulsory, and that's why that's why I gave this whole rant about class attendance just now, because class attendance is very important and it can backfire on someone. So I don't know if the recordings are just available for students that attended. To my knowledge, all students that are part of this group and aren't, let's say, guests of this group, they have access to the video, whether they attend or not. So I know some of the students, they log into these sessions as guests, and I think it might be those guys that are struggling to get access. So you can see here on my screen, there's meeting guest, meeting guest, meeting guest. So I think guys like that might not get access to the video recording, but all the other students here, they will have access. I think that's how the software works.
Okay, thank you, sir.
Thanks, man. All right, great, guys. Let's get on with the lecture. It's not a long lecture. I want to talk to you guys about maintenance and support concept today. Remember, we're talking about bringing systems into being. Eh? So it focuses on the first part of the design, the preliminary design of a system. So sorry, guys, my voice is shot after the weekend. So I'm taking sips of coffee in between. So if I'm quiet for about 5 seconds, don't get worried. I'm still here. But nonetheless, so today our slides are about conceptual system design. So if we go back to this table, we're talking about this part of the design, conceptual design. That's what chapter 3 is about. And you might notice that we are talking about chapter 3 and chapter 4, and chapter 4 is preliminary design. So in these two parts, we outline the rest of the life cycle. That's why we haven't included those chapters. But nonetheless, so this is where we are. That's what we're talking about. So chapter 1 and 2 was introductory. The first one is what is systems. The second one is what is the life cycle. Chapter 3 is going into the detailed design, which is into the design process, which the first part is conceptual design. So that's where we're at. Okay, so that's what we're talking about. So if we go back to where we are, part of the design, remember we're talking about life cycle, and I said, okay, but we can't just design a product. That's not systems engineering. Systems engineering is designing the product and considering the entire structure around the product as well. So it's not just the product, it's about the company. So it's the products and it's the support and it's the other segments of the company that actually sell the product and service the product and all of that. And all of that has to be designed right through the life cycle. If you remember that life cycle chart of ours, where all those different steps are, you remember those little arrows that we did in chapter 2. Let me see if I can open them. Chapter 2. Let's just, this arrow, remember? So this is what systems engineering is about. It's not just about this one stream where the product is designed. It's actually, it incorporates all these other streams. It doesn't just include the product, it includes the manufacturing of the product, it includes service support, and it also includes phase out and disposal. So all of those aspects are included in systems engineering. So if we go back to this, one of the important parts, remember I showed you an example. If you have to decide to buy a car and you're comparing a VW Polo to a Nissan Micra, and you go to those spec sheets, one very important part of the spec sheets for the company as well, because the company producing the car also spends money on that, a lot of money on that. All right, so it's a big component of the car's cost that they talk about service plan and warranties and all of that. So all of that has to be incorporated into the product design. So the prime system elements must be designed in such a way that they can be effectively and efficiently supported through the entire system life cycle. The maintenance and support infrastructure must be responsive to this requirement. Okay, so these days, back in the day, when they built those steam cars and Henry Ford started producing the first commercial cars from a moving production line, you know his whole story. Back then, there wasn't really after-sales service and support in the form of maintenance plans and warranties and that type of stuff that is included in the product's price. It was basically you buy the car and you maintain it and it's your baby. Once it rolls off the showroom floor, then it's your baby. And that's why many of those guys, if you owned a car back in the day, you had to have the tools to be able to support it. These days it's a little bit different because when I buy a car, I don't just buy a car. I go into a contract with the guy that's supplying the car to me. And that contract says when I pay for this car, that company undertakes that they will service the car for the first 5 years or whatever the service plan is. They also undertake that from that list of components that's included in the warranty, if any of those components break, they will replace it for me for free in the warranty period. So I don't just buy a car. I buy a relationship with the manufacturer. I buy a contract, an agreement with the manufacturer. Right, so that's what those type of stuff looks like these days, and it looks like that in many regards. I often refer to my cell phone because my cell phone is always here next to me on my desk, and when I look around, that's the first thing that I see. So even with cell phones these days, I've got a normal iPhone 12, just the plain midstream one. And when I bought it, there was an option for Apple Care or iCare, I don't know what they call it, but Apple Care, which is also basically a warranty. If something breaks, they'll replace the screen, and if the battery goes, they'll replace it, or whatever the case may be. So there's also an agreement. So it's not just with cars or big products, it's actually with smaller products these days. Apple's also got a returns policy where I can take this iPhone 12 of mine, I can take it in, they give me a certain amount of money for it, and I can buy an iPhone 13 with that discount included because I gave them my old phone. So that after sales service and support must obviously also form part of your design. So I can't just design an engine. When I design an engine for a car, I must consider the parts that goes into that engine and how those parts will be distributed. I told you a story last time of this Audi A1 that my wife drives. It's an old one. 2011, 2012 model, but nonetheless, the water pump went, and we took it in and they replaced the water pump. Now, if you design a car and that component is in the car, but you can't distribute it, you can't replace it or whatever, then obviously you're not filling the requirement of the customer. The customer is, I'm the customer, I want to, my water pump is shot. If I leave that water pump, the car is going to overheat and it's going to seize and the whole engine is going to be gone and I'm going to throw the car away. There. But I want to replace the water pump. And where do I go to replace the water pump? Is at the dealership, at Audi. So that's a requirement that I have as the client. So the whole system must be designed in such a way that the product cannot just be supplied, but it can also be effectively and efficiently supported through the entire life cycle, from the day it's bought to the day it retires. So when one day this car is shot, how will it be retired? When my phone is done, how will it be retired? So I'm very impressed with Apple's approach with this returns policy, because they actually focus on that disposal side, recovering content or recovering precious metals or whatever from the phone. And it's the same thing with the cars as well. So you have to consider that end of life as well. So the entire system lifecycle has to be taken into consideration. And a very important component of that is maintenance and support, like I just mentioned. Okay, so maintenance and support concept exists whenever there are requirements for corrective and or preventative maintenance at any time throughout the system lifecycle. Now, later on in chapter 8, I think, we'll talk about corrective and preventative maintenance, but what it basically means is preventative maintenance is scheduled maintenance, is maintenance that you do so that this thing doesn't break. Corrective maintenance is what you do when the thing is already broken. Now, when there's a breakdown or there's a failure, then you go in and you correct the error. So to give you an idea, preventative maintenance is an annual service that I do on my car. Corrective maintenance is that water pump that I had to replace because it was broken. Okay, so maintenance and support concepts exist whenever there are requirements for those two components. And in most cases in the world today, in most products that you supply, that is a requirement. We bought a laptop for my wife. She's also working from home. And her old laptop from 2009 was shot and done. So we drove and we bought her a new i3 Dell laptop. And it was very quick. It was very impressive for a normal i3 laptop. And she had it and she worked with it. And 3 months in, that laptop became slow. And it became slower and slower and slower and slower, up to the day where you can't even open a browser. And we spoke about it and we can't understand what's wrong with this laptop, and we formatted it and we reinstalled all of the software and it was still slow. And I opened that taskbar and I saw that the system memory is full the whole time. And I realized that maybe it's a hard drive problem. And we took it in and Dell replaced it. Dell replaced the hard drive. So even with laptops, that's corrective maintenance is required. Preventative maintenance, obviously, on this type of products usually comes in the form of software name. So there's software patches and updates that you download continuously. These days, it's nearly every evening that you download updates. With Windows, those updates are usually very frustrating. But then there's also corrective maintenance. So every single product that you design, this must be taken into account. Okay. Maintenance and support concept generally includes the following. It's the level of maintenance. So there's a division of functions and tasks in the area of where the maintenance is performed. So that basically means, I bought a Nissan. My car is a Nissan X-Trail, and it's got a very long warranty. I think it's got a 7-year warranty. But when you go into the fine print, there's certain parts that's included in that warranty and certain parts that aren't included in that warranty, right? For instance, like brakes and that type of stuff isn't included in the warranty. But there's big mechanical components like the engine and the drivetrain and the gearbox and all of that is included in that warranty. So that's the level of maintenance. And then repair policies. Repair policy may indicate that an item should be designed in such a way that in the event of failure should be non-repairable, partially repairable, or fully repairable. So a good example of that is that water pump that broke on that Audi of mine. So that Audi the water pump broke. I took it in and they replaced it. They didn't try to repair it. They didn't put in new bearings, right? So in the event of failure, is it non-repairable, partially repairable, or fully repairable? Fully repairable means they can strip that water pump down and they can panel beat it, right? So they can bend this part or bend that part so that it runs again. Partially repairable means I can open up that water pump and replace the bearings or replace the impeller. Non-repairable means we take that water pump off and we throw it in the dustbin and we put on a new one. It's non-repairable. It has to be replaced. Okay, so that gives you an idea of the repair policies. So some components on a car are fully repairable, even though most policies these days move away from fully repairable to partially repairable. What I mean by that is, for instance, if you drive a car and you're in an accident and you take it to the panel beaters, do they take that that body panel that broke and do they bend it and put it back where it was, or do they replace that body panel? Okay, so we are moving more towards partially repairable or even non-repairable. So some of that stuff is even non-repairable. So I know that those policies do change, but that's the repair policies. And then organizational response. Yes, yes.
What's the motivation in the movement towards partially and instead of fully repairable? What's the motivation behind that for manufacturing companies?
Yeah, it's a very good question, but it's not an easy one to answer. Remember, we've got a complex network of supply chain and interrelated companies that all have to make a profit. Né? So if you are VW, what makes business sense for you? To reduce the cost of replacement parts or to manufacture a very good quality part that can be fully repairable. So if I was VW and I design my body panels, I would design them in a way that it's very cheap, because in that way I don't only sell the car, but I also sell the parts on the sideline, which makes more money. And by making it cheaper, say by composites or whatever, when last did you see a bumper that wasn't plastic, that wasn't a composite? So I would make it in that way that makes it easily assemblable, low cost, and easily replaceable, because then I diversify my market. I don't just sell polos, but I sell polos and all the sub parts. And then down the supply chain with these repair centers or panel beaters, it also makes more sense to me to say, okay, but there are 3 bolts on this bumper that I must loosen and put on a new bumper and it's done. Instead of saying, okay, but this bumper is bent, it's metal, so I have to have a specialist metal worker, and he sits there with a hammer or a tool and he sits there for 4 days trying to beat this thing back into shape. So it makes more sense, I think, economically for everyone to move in that direction. But obviously, what I'm talking about is just a special case. In other cases, it doesn't make sense. So if you build a power station or whatever, and there are pumps on the power station, when one of those pumps break, it doesn't make sense to just replace it, because it's a high cost, long life cycle component. So if a pump breaks, I can't just go back and say, okay, let's throw this pump in the dustbin and replace it. It's too big, it's too expensive, its life cycle is too long. So in that case, I would make it either fully repairable or partially repairable. So it would be made in a way that you can actually strip it down, replace individual impellers or individual bearings or so on. So it depends on the application. But in most cases, things tend in a direction that makes more financial sense for everyone in the supply chain. So I hope that answers your question. It's not an easy answer, because I can't tell you this is the reason or that is the reason, because you have to consider the case. But I think it's more related to company profit and supply chain stability, if I can put it that way.
Yeah, the answer makes sense.
Great, thanks, man. Mr. Mashlangu.
Good morning, Doctor. I understand the financial concept behind it, with the involvement of cars. But don't you think it's a maybe decrease in quality? If we take, for example, the body shells, as you were talking about, panel beaters, the Toyota Cressida from back in the days, if you would compare it with what Toyota manufactures now in terms of the body shell, would you say it's a decrease in quality? I understand the financial concept behind it, though.
Yeah. What I remember the definition of quality, né? The definition of quality is not to build something that lasts forever. The definition of quality is to closely match what the client needs or what the client wants. That's quality. So if the client wants something that he can just replace easily, and you build the old Toyota Cressida, then obviously it's not quality, because then your company isn't lean. You're overshooting on your quality targets. Okay, so yes, I agree. It is quality-centered. Why? Because quality-centered is client-centered, and client-centered means that you are selling stuff. Okay, so in your comparison, and I want to answer that with a question. Inflation happened and the world happened, and our economy is in such a way that back in the day, in the 1970s and 80s, this is a big thing from the USA that emerging people are struggling with. Back in the day, in the 1970s and 1980s, there could be a one-income household. In that case, it was just the dad, just the father, just the man in the house worked, just him. And they could afford 2 cars and a house. These days, with a single income household, you stay in a small apartment on whichever floor of the place. You don't own a car, you take public transport. So economic circumstances have changed in the more modern world, right? Because of competition and all of that. Now, if you are Toyota and you produce a car to the level that the old Toyota Cressida was, and I know why you're referring it. My wife's grandfather drives a Nissan Sentra, also from back in the day, 1970s, Nissan Sentra. And that car never stops. It just keeps on going. It doesn't look good anymore. It's half rusted down, and the windows are bleached from the sun and all of that, but it never stops working. It just carries on. Now, my question is, with economic circumstances and the cost of raw materials, how much will it cost Toyota to produce a car like the old Cressida today? Okay, how much will that car cost? Now, if you are a client and you sit in these circumstances where in a single income household, you have to rent a place to stay and you can't own a car. Now, all of a sudden, the new Toyota costs 400,000 Rand, which is already a lot. Imagine if Toyota had to produce it in the way that they produced the old Cressida, how much would it cost? 2 million Rand today. So there is economic sense in moving a product to a certain direction in present circumstances. Yes, we can look at the economic world and say it's very unfair, because back in the 70s, you could buy a house and buy a car, all with a single income, and these days you can't do it anymore. So we can sit back and moan about the past, or we can sit back and look at present circumstances and adapt. So in that case, I think we mustn't say that cars aren't the same quality as they were back in the day. What I think is what we must say is cars are produced for something different today than they were back in the day. Back in the day, they were produced to last a lifetime. Today, they are produced so that the clients can stay fashionable. In 2 years' time, there's a new facelift that comes out. In 4 years, there's a new car that comes out. So why design a car that will last 100 years when the client will buy a new car in 4 years' time in any case? It's not a simple answer. I think it's a complex answer. But I hope that I could have given you some insight.
Yes, definitely. Thank you, sir.
Great, man. Thanks. Remember, yes, target is still quality, and target is still client satisfaction. And maybe because client needs have changed, the companies have responded, and they are producing things to different quality standards these days. All right, so that's organizational responsibility. The accomplishment of the maintenance may be the responsibility of the customer, the producer, a third party, or the combination thereof. Those pumps, those large-scale pumps in the power station is an example of that. So the maintenance there is actually more customer-based than it is producer-based, right? So those huge pumps that you can nearly drive a car down. Eskom and Water Affairs and the water boards that own those pumps, they've got a whole maintenance section that obviously buys parts from the producer, but they maintain it themselves mostly. So there, the maintenance is the responsibility of the customer, whereas with a car like this, with a car like my Audi, the maintenance is paid by the customer, but the responsibility of the producer or a third party. So you can see how those responsibilities change from product to product. Now, so something like a cell phone would most probably be third party, because if I take it to the shop down the street, it's going to cost me a lot less than when I take it back to Apple themselves. So there, the responsibility is mostly third party, and they have to buy parts for it. So that's the responsibility of these maintenance and support items. And then maintenance support elements, as part of the initial maintenance concept, criteria must be established related to the various elements of maintenance support. What are the different elements of maintenance support? Is client contact and engagement with the product, and then obviously supply chain that includes warehousing and stock. There's distribution and logistics, and then there's production of spare parts. So there's an entire network there of support elements. So who is responsible for what part of those support elements? So the factory, let's say I buy what car is produced in South Africa. Let's say, what's it, the BMW 3 Series. Yeah? So the dealership, the BMW dealership has got nothing to do with the factory that's based in, it's not Roslyn. Is it Roslyn? I'm not sure. Anyway, the factory, say again?
Yes, it is Roslyn.
Roslyn, yeah. So they built the BMW 3 Series there in Roslyn. Now, the dealership here in town, it's got nothing to do with the factory. Between the dealership and the factory, there's a big link in terms of supply chain and distribution, but they're not related. So if you drive to the dealership here and you ask, listen, who works at that factory, they're not going to know, because it's two different components. It's two different elements in the support system. So yes, it carries the same name. It's both BMW, but they're responsible for different elements of the maintenance support structure. So in that way, how is that structured? How is that built? I spoke to you about Nissan, that has a very interesting production or manufacturing concept where they have the different factories that are mostly run independently, where those different factories apply to produce a new model. For instance, a while back, it was a year or two back, our Nissan factory in Roslyn applied to produce the new Navara, and they won the contract actually. But it was a big competition between them and other plants in different places of the world. So it's sort of internal competition, which is very interesting for me in a company. So it wasn't a corporate decision. It was a corporate decision to choose who they're going to use, but it's up to the plants to reach a certain quality level to be able to win that new product. So it was very interesting for me. But in that way, what it comes down to, there are different elements even within a company. It's not just third-party part suppliers and distribution logistic networks. It's actually within a company, there are also different elements. So how are you going to structure those elements? That's also part of your system design. Okay, so effectiveness requirements. These constitute the effectiveness factors associated with the support capability. For instance, I always come back to the same example, but I think it's a standing example, so we are familiar with it. My Audi A1, which the water pump broke. I called the guys on Tuesday. I made an appointment for the Thursday. My car went in the morning, 3 o'clock the afternoon. They called me and it was done. It was finished. So in that time, they sourced a replacement part. They booked space in the service environment or in their facility. I took my car in. They gave me a shuttle. 3 o'clock the afternoon, that part was ordered, supplied, distribution, replaced. The car was washed, it was checked, it was tested, and it was done. So that says a lot about effectiveness. And I think that talks to that whole Cressida scenario as well. If I were to take my Cressida in and say, listen, replace this part, and it's only partially maintainable or fully maintainable. It's going to take a lot of time. I'm going to take in my car on Monday, and I'm going to receive it back in 2 weeks' time, and they're going to have a specialist there, and we're going to wait 4 weeks for parts. So that's not very effective. Okay, so effectiveness requirements. What are the effectiveness requirements? Because our world is moving at such a pace, I had the freedom to be able to call them on Tuesday and have my car fixed by Thursday. It cost me a load of money, but I think that was very effective. And then environment, definition of as it pertains to the maintenance and support. All right, so what is the environment in which I'm going to maintain it? With a car, it's very good because they've got a dealership, it's there. I bring my car to them. But if we're thinking about those big pumps in the power stations, say it's a Sulzer pump. Now, Sulzer have to come from Germany, fly down to South Africa, drive into the mountains, where there's no facilities and the environment isn't conducive to actually maintain that product. It's all on site. Right. So what is the environment within which this maintenance and support structure happens? So that also has to be in consideration. For instance, I told you about those big pipelines that we built. So they've got those valves there. And guys, it's valves that you can drive a car through. OK, so it's big valves, taps, valves. So they're buried underground. And we cast a concrete valve chamber within which this valve sits. So obviously I have to keep maintenance and support in mind when I design that valve chamber and choose the valve, right? So I can't design a valve chamber that's so small you can't swing a spanner and replace it. So I have to take all of those factors into consideration when I design the product, and like the environment. A good example of that, mines, down there in the mines. What's the rule of thumb is 1 degree Celsius hotter for every 100 meters that you go down. So if you take that in consideration and know that South Africa has the deepest mines in the world, Mponeng mine, they're close to Carletonville, I think broke 4,000 meters now. It went deeper than 4 kilometers now. It's either Mponeng or Savuka, because I know those 3 mines are competing as the deepest mine in the world. So I think Savuka mine, close to Carletonville, now dropped below 4 kilometers. And if you say 1 degree Celsius for every 100 meters, that means if surface temperature is 25 degrees Celsius on a cold day, 4 kilometers down, it's 25 degrees Celsius plus 40 degrees Celsius. That's how hot it is down there. So it's 65 degrees Celsius down there. So they have to cool it down and all of that. But now can you imagine maintaining a valve pipe set in the dust and in that heat down there? So how are you going to design your product? How are you going to maintain and support that product when you consider that working environment? All right. That's just an example. Okay, guys, I think we're going to stop it there with maintenance and support, and then we'll carry on next week, Tuesday, with technical performance measures. Okay, so we're going to stop it there. Guys, I gave you a lot of examples today, so maybe you've got a question or something that you'd like to mention. No questions. I'm always scared when there's no questions because it means one of two things. Either I'm such a good lecturer that I've answered all of the questions in how I talk, or I'm such a poor lecturer that you guys are lost and you don't even know what to ask. So guys, please chat and ask questions. Let's engage. Mr. Gressa.
Morning, Doctor. Just with regards to the valves I was talking about, when do you plan to design these valves, right? Do you set in mind when designing, okay, most probably these mines in the next 10 or 15 years are going to reach further than maybe 4 kilometers down into the earth? Or is there a certain tolerance that you need to adhere to every time? Because like I said, maybe 10 years ago when they designed that valve, they didn't know that people will be digging underneath the earth 4,000 meters down the earth.
Yeah. It's a very good question, and the mines is a difficult example because those mines, I don't believe they were ever meant to go that deep. most of those mines are quite marginal at this point. They have to go so deep that it costs them so much that it's become a very difficult industry to work on. To give you some background, I'm working with the University of Stellenbosch, and they've got a research center based here in Pretoria. And those guys work on the mines. So when I was doing my doctorate, I helped design a piece of software, or actually I designed the piece of software. I never wrote it. The company took the software and they developed it further. It's called Process Toolbox. I spoke with Stellenbosch University in advising a doctoral candidate the other day. And he was investigating deepening projects in those mines that talk precisely to what you spoke to now, where they go and they say, okay, what's the impact on the infrastructure needed to support that mine? So say cooling, say wash water, say extraction of ore and personnel support and all of that infrastructure. What is the impact of a deepening project on that infrastructure? And he used the Process Toolbox to investigate if they deepen, what will the effects be on rock face temperature and environment temperature with a current cooling supply and all of that stuff. So he had this beautiful piece of software that before they start a deepening project, they investigate all of this and what will be needed in terms of these valves and stuff. And I asked him, this is a great project, it's awesome, but how do they do it at this point? If only now someone with a doctorate, which means it's something new, is coming and saying, but let's do an integrated design of this mine with a deepening project, then how have they done it previously? And he told me that most of those mines work in individual sections. So there's a cooling section, and there's a dust extraction section, and there's a personnel support section, and all of that, and they work in silos. So it's a good question, but it's a very scary answer. Those mines were never designed to reach 4 kilometers deep and have a footprint of, say, 100 square kilometers underground. They were never designed for it. They just grew and grew and grew and grew. And at this point, it's an ad hoc way of designing. So the mine goes and they reach a lower level of the ore reef, and they investigate the deepening levels. So the surveyors and the miners go and they say, okay, listen, we want to deepen to 4,000 meters and expand this reef by 400 diagonal meters. This is what we're going to do. The surveyors go in and they choose where to blast and expand. And that problem then comes to the cooling engineers, and they say, listen, okay, we're expanding this mine by 400 square kilometers. This is now your problem. And they come in and say, okay, but we have to cool this now. What valves are we going to use? Then they choose off the shelf valves and stuff. So it's a good question, but it's not an easy answer to hear. It's actually a very scary answer to hear. So in a perfect environment, you will select valves, and the valve suppliers will also recommend a certain valve that can work in that environment. But if you've ever gone down in a mine, if you've ever been down there and you had to crawl on your elbows and your knees, then you get a different respect for those miners and what they do. And then you realize that design environment is something that us as clean engineers behind a desk, we don't really understand. So we can say, and we can take the depth of the mine, and we can take our probes and see what the temperature is there and design a certain valve chamber of a certain size to accommodate this valve. But once you get down there, it's a different story, okay? Just to give an idea of what a different story it is, those cooling pipes, remember, it's 4 kilometers down. That wasn't 4 kilometers, it was about 2.5 kilometers down when I saw this. But working down there in the mines, there's cooling water being cooled on surface, being pumped down, heated down there by cooling the mine, and then pumped back up. So obviously it's very energy intensive. Every single liter is very energy intensive. When I got down there, the miners went and they packed a couple of stones below one of these pipes, and they took a big spanner and they cracked a hole in this pipe. And that pipe is basically leaking water over these stones so that they can keep their cold drinks cold. And you can't blame them, because when you walk there, it feels like an oven. That day it was something like 36, 37 degrees Celsius down there. So you literally can't breathe. That's how hot it is. So you can't blame them. But obviously, they're not working with the mine because they're breaking the infrastructure just to be able to create a better environment. So it's a good question, but it's not an easy answer to hear. I hope I did answer you on the example of mines. Mr. Yes, Mr. Gressen.
No, sir. I just thanks. That's adequate.
Right. Mr. Kilibeni.
Morning, sir.
Hi.
So my question is, how does companies cooperate with each other in terms of materials? Like, for example, on our last class, you mentioned that your wife's ODA1 is using VW engine. So can you make it clear for me on that one?
Okay, so there, you're right in saying that there's big company collaboration in terms of parts, but it is actually not what you think it is. To give you an example, VW again, the plant that supplies the filters, they make two filters, and the difference between the filters is the color of the paint on the outside. So this company produces a fuel filter, and in the spray booth right at the end of the production, it goes into two booths. In the one booth they spray it blue, and in the other booth they spray it grey. And the grey one costs 800 Rand, and the blue one costs 200 Rand because of the label that they put on it. Okay, so the one is a FAG or a FAG filter, and the other one is a VW filter. Okay, and it costs more through the supply and distribution chain. So to answer you, it's not that necessarily VW and Audi working together, even though they do. It's the two companies that have a similar supply chain. So when you produce a car, you're not going to produce every single part in that car, right? So I am now VW, I'm producing a Polo. But I'm not going to have a factory for every single valve, for every single piece of plastic, for every single engine mount, for every single button inside the car. I've got suppliers for those. There's a company that makes car radios, and they supply car radios to VW. And VW gives authorization for them to put a VW badge on it. Like VW went and they said FAG or FAG filters. You are now supplying us with filters, so we give you the right to spray those filters grey and place a VW sticker on it. Okay, so yes, there's company collaboration, but not in the sense that we think it is. It's more in the sense of a supplier network. To give an example, Gibela, our research professor at the Department of Industrial Engineering, Prof. Mpofu, he's the research chair or the research wing of the Gibela guys. They've got a train production plant there in, Vereniging somewhere. I'm not sure where it is, but nonetheless. And they, with that train production, they also, with that new plant that they put up where they're going to produce trains, they also set up a supplier park that can supply parts. And they are now incubating companies that can produce the products that they will use in the production of those trains. So that plant is not going to produce every single mount and every single piece of iron and every single wheel. They're actually setting up a supplier park of different companies that can supply those parts. So in the case of my Audi A1, like you mentioned now, that's water pump. It was a VW water pump that they put into the Audi, but it's not a VW water pump. It's a water pump that has a VW badge on it, but it's actually supplied by a total third-party supplier company. And that's why that water pump is a standardized product that they can use in the A1 and in the Polo and all of those different cars. So I hope that gives you an answer to your question.
Oh, yes, thanks.
Excellent. Thank you so much, guys. With that, we are going to write our Chapter 1, Chapter 2, and Natural Science test next week, Thursday. Okay, so we've got a lot of time to study. I know it's Easter weekend, so most of you guys are going away or going home or going somewhere for Easter weekend. That's why it's next week, Thursday. I will communicate the time. It will be a 2-hour online test, and we will be using the Invigilator app. So I'll give all of that information to you online. All right. Miss Kleine.
Yes, sir. So I wanted to say something regarding the date. Isn't it early? Because some of us will be away already. Can it be after the Easter?
It is after Easter.
Because
This weekend is Easter. It is after.
So what's the after Easter? Which date?
Thursday next week. Thursday next week is the 14th of April.
So Easter is next week. It's not this week.
Yeah, it's next week. It's 14 April. Oh, Easter weekend. Is it the 15th?
Yeah, it's the 15th, sir.
So it's even before Easter. So you guys have enough time to study. So there's even nothing in the way this weekend. So you can study for that test, write the test, climb in your car, and go on Easter.
Sir, but you're even writing on the 13th.
You're writing on the 13th. Okay, but we are writing with this
Yes.
on the 14th. Sorry, I don't see what the worry is. A week, I think, is a lot of time to study the introductory chapters. Okay, we'll write it in, guys. Let me just go somewhere quickly. All right, so April 14th. Can you see it's yellow? Yeah. Yellow means classes, contact days. So yes, the 15th is a public holiday, but the 14th is a full contact, let's say, university working day. It's not a holiday. It's a full university working day. So if you guys go on holiday for that day, that is taking holiday within the school calendar. So then there's nothing that I can help you with. The 15th is a public holiday. This 18th is a public holiday. So there I will be exceeding my mandate by asking you to write a test. But the 14th is a full school day. So I won't be exceeding my mandate if I ask you to write a test then. Does that make sense? All right. Thank you, guys. So that test will then take place in class time. So it's this time slot that we are in now. It will be a 2-hour online test. We'll be using the Invigilator app. All right. Thanks, guys, and thanks again. I will then see you on Tuesday. I hope you guys have a good day and have a good weekend in front of you. I was under the impression that this weekend is Easter, but now I'm wrong. All right. Thanks, guys. Have a good day. I'll see you soon. Check the announcements for test arrangements and so on. Thanks, guys.
Thank you, sir.